Say again.
Our questions are quite different.
Oh, it's the same lah. It's just that they rephrase it. That's all. This is an old question. Your page is a new question. They rephrase it only. Answer is
Oh,
just the other way around. That's all. Forgotten to change it. Yep.
B.
Huh? Electron will flow from Y to X. Then the other one is to calculate huh? Rate flow of the rate flow and direction of flow of current of electron through the resistor. So that is your definition for current. So you want to find N over T. So N over T, take the E down there, put the current, there's a current, there's the charge of the electron from the data sheet, and calculate out. So answer is 0. Okay,
Yeah. Sure. Teacher, is negative to positive or positive to negative?
electron will flow from negative to positive,
Okay.
whereas conventional current, which is a flow of positive charge, will go flow from positive terminal to negative terminal. Okay, 65. When there is no current in the wire, which statement about conduction electron in the wire is correct?
No current.
Yep, no current, so what's the answer?
A.
A. Huh? The positive ions is vibrating, not the electron. About fixed point. Hi, Rishan. Using the resistivity formula, that's all. Okay.
Hmm.
Which of the following describe the electric potential between 2 points in a wire that carries a current?
Is it raining heavily?
Yeah, very heavy rain. Yep.
Uh, A.
C.
Oh, okay.
Right? Definition of potential difference is energy over charge. So it's power over current. Okay. Same. Find the charge first, then find the current. Right? Definition of potential difference. Right? Replace your Q with IT and put in what is given. Energy is given. Energy, potential difference, to work, current, right? T 15 minutes, 15 seconds. Okay. A, anything not clear?
Sure.
This is called a log linear graph lah, which convenient way of plotting log resistance against temperature lah. No need to go and log it, you just treat as a log paper lor. That's why the scale is non-linear. Yep. 40 degrees. This 100, this 200, 300, 400. Okay or not?
Okay.
Yep. This copper wire C surrounded by a steel core S, 1 kilometer of one of copper wire has a resistance of 10 ohm, and 1 kilometer of steel core has a resistance of 100 ohm. What is the approximate resistance of 1 kilometer of the power cable? You have to decide whether the wire is in parallel or in series. Right? Copper wire and steel wire are in parallel. Total resistance of copper is 10 divided by 6. There are 6 of them parallel. So divided by 6. Which is 10. So it's 5 over 3. And resultant resistance, right, is in parallel to 1 over 5 over 3 for copper wire. And then 1 over steel, 100. Then work it out with your calculator. Boy, okay or not?
Yeah.
How about this one? Right? And X is high potential. And there's a the potential drop across 4 ohm is larger. So answer is donkey. X is at a higher potential, Y is at lower potential. Across the resistor, the potential decreases and constant across the wire. That wire, no resistance, the potential is the same. PD across the higher resistance is greater. PD across this one for ohm is greater than 2 ohm, that's why it's steeper. Okay,
Yeah.
draw a picture to show you. Have a picture in mind how it is saying what's the charge that flow during the time. Calculate area in the graph. Right? From the formula, charge is current times time. So area in the graph. That area of trapezium. Can or not?
We got 480.
Area
Yeah,
under the
see.
graph. You can find area of triangle plus area of rectangle. But make sure you convert that to ampere. Okay. So I take
Sure.
trapezium. Trapezium is 100 plus 20. Right? Sum of parallel side. Convert to ampere times 8. And divide by 2. Okay, try this one. It's similar to what you study in your STM, Bernoulli's principle. Electric current passes from thick copper wire to a section of thinner copper wire before entering a second thick copper wire as shown. Which statement about the current and the speed of electron in the wire is correct? Huh? Apply your knowledge. Resistance in series, current in the resistor is the same. If it's in series, that's the first point to understand. Current in series resistor is constant. Then apply this formula. NQAV, right? Number per unit volume, is a charge that is flowing as a cross-sectional area. That's the speed, the average grid velocity. Right? Since they are copper, all of them are copper. N is the same, Q is the same, constant. I is constant. So AV is the one that is constant. So where V is greater in thinner wire, as A is smaller. Thinner wire, V is greater. So answer is C.
Okay.
Okay, let's try a structure question before we go to DC circuit. You want a class next Thursday? You want a class on Thursday?
Sure.
You want a class on Thursday? Or you want to think about it first?
Yeah, I want a class on Thursday.
I think we have one session will do lah. Rather than two
Yeah.
sessions. It's too tiring for you. You tell me what time you want to start lah. A straight wire of unstretched length L has a electrical resistance R, where R is when it is stretched by a force, the wire extends by an amount delta L. The resistance increases by delta R. Area of cross-section A of the wire may be assumed to remain constant. State the relation RLA and resistivity rho of the material of the wire. This one is memory work only. First question to encourage you to do something memory work. Can you remember? How are they related?
Uh, one by one. I think.
That's the formula. Memory work only.
Yeah.
Then the next part we just use, think of it as differentiation, no? Right? Changing one to delta y, this delta x, right? Strain is delta L over L. And this is rho and A constant. Delta R, delta L. So dividing, this one divide by that one there. So rho and A will cancel off. Delta R over R and delta L over L. Okay or not?
Yeah.
Steel wire has a cross-sectional area there and resistance 4.17 ohm. Young's modulus is given. Tension, the wire increased from 0 to 72 cm. The wire obey Hooke's law. At this value of tension, determine the strain in the wire and hence the change in resistance. Express your answer to the approximate number of significant figure. So it should be three significant figure because all the value are given to 3. Yep.
Okay.
Go to Young's modulus. Stress over strain. Young's modulus is given. Young's modulus is given. Stress. Right? There's your force over cross-sectional area. There's your cross-sectional area. There's your strain. You find your strain. No? There's your strain. Then we are just using this formula, that's all. After that, and we have derived. Yep. Can?
And
Okay, let's go to DC circuit. Okay, we are now on page 371. All this formula you need to remember. Resistor in series, resistor in parallel, potential divider, Kirchhoff's law. Formula for resistor in series, resistor in parallel, potential divider. Okay, what's the answer for this one? We are now in the DC circuit.
then use Kirchhoff law, is it?
No, potential divider. Either you memorize it or you work it out. No? Pay you to memorize it lah. Yeah, cannot memorize it, work it out. No? Find the current. Right? Current times that times the sum of the two resistors is the potential difference across the both of them. No? And I cross multiply R2 over R1. Then V right, is I times R, I times R1. So I is that one. This is R1. Okay, B.
All right.
This one. Potential difference is 3 volt across XY. What's the current in the 5 ohm resistor? Yep,
Um,
just V divided by the total resistance. Yeah, PD across 8 ohm. Either one is 3 volt. Current in 8 ohm resistance is V over R, right? 3 over 8. The answer is A.
okay.
Okay,
Okay.
what is the answer? Here is 2 volt. So it tells you R1 and R3 are the same, but the resistance of R1 and R3 are double that of R2. Then go and check which is the possible one. Right? R1 and R3 are the same. R1 and R3 are the same, either A or D. But we are told we can deduce that from here 2 volt, here 1 volt, current is the same. So it means the resistance is double. So answer is A.
Okay.
Okay,
Yeah.
try this one. Network of resistance, each of resistance R. What's the effective resistance between X and Y? Yep. Replace the one first, so then replace these two. Right? Doing step by step. Right? That's the original circuit. Right? Replace this one. This 2R. And replace this one. Right? Replace this one becomes that one. Right? This one, these two multiply together, add together, or you can do your own way. 1 over R. And replace this one. Okay or not? Step by step.
Okay.
Okay. This one. Yep. Why take so long?
I will.
What's the answer?
I think it's C lah.
Yeah. I1 and I2 are in the same direction. So both going in. Then I3 and I4 must be going out.
Oh. Oh, in that
Cannot be
case, it's not.
donkey. Donkey all going in, that's not possible. A cannot be. Right? I1 and
Repeat.
I2 are different. I1 and I2 are going out, but I3 is also going out, so cannot be. So answer is C. Lor. We are using Kirchhoff's current law. Some are current entering junction because some are current leaving junction. Okay,
Yeah.
Yep. Memory work.
Sum of currents. This one should be second law, right? No,
First
it's the
law.
first law.
Current is first law.
Oh,
Conservation of
okay.
charge.
Then
Second law
what's the
is
second law?
conservation of energy. Okay, now.
Yeah.
Okay. Combined resistance RT of two resistors R1 and R2 connected in parallel is given by the formula. Which statement is used in derivation of this formula? Yep, parallel.
Is it A?
No, they are not the
But I
same.
think A is the potential difference, right? Supposed to
Ah,
be potential,
potential different.
not current.
Resistor is the same. Okay, now.
Yeah.
Where donkey is for Kirchhoff's second law.
Oh,
Yep, that's the answer.
I think they do not like.
What's the answer?
What else?
Basically, the circuit is the same. These two in series. These two in series, but they are in parallel to that one. These two in series. These two in series, but they are in parallel.
Oh,
Answer is C, same brightness. Circuit is the same. You just call it differently, that's all. We can call this one Q. We can call this one R. I can redraw that. This one, can put a battery inside there. And then turn it around, that's all. Nothing much. They are the same. Okay,
yeah.
got 10 more minutes, that's all. What is the effect of increase on the potential difference across XY and on the position of the movable contact for zero deflection? Yep. Basically, there's a sharing of this is the source, sharing of the source of EMF with this one and the resistance XY, that's all. So if you increase that, then there will be less across XY. This is constant. So if XY is less, then it must go to near Y. Okay, not? Donkey. Ken, anything not clear?
USB one need to go near to Y again.
Ah, basically this sharing. This is the source.
Okay.
We share the PD with this variable resistor and the resistor of XY. That's all. So if you increase this one, then more will fall across this variable resistor, less PD across XY. But this is constant, so you must move it towards Y.
Okay.
Okay, potential divider. What's the range of voltages can be obtained between P and Q? Yep. If the resistance 0 here, then the PD across here will be 0.
7.5.
So the
7.5.
largest it can be is 7.5. Right?
Yeah.
50, add these two together, times 9 is 7.5. The answer is B. No?
Yep.
Right? Just replace these two resistors with one resistor. No? What's the current? Right? Find the potential difference across that resistor across here, then you can find the current. No? Right? Replace that resistor. They are in parallel. 6 times 3, 6 plus 3, 2 ohm. So 2 ohm, 2 ohm. Right? So there will be 6 volt across here. There's 2 ohm here, 2 ohm here. So 6 volt across this combined resistance. I can calculate a current. Can or not?
Mm.
If you can do mentally, be quite fast. No need for all this calculation. Diagram shows a battery, a fixed resistor, ammeter, and variable resistor connected in series. Voltmeter is connected across a fixed resistor. Value of the resistor is reduced. Okay. Sorry, this one is incomplete. Looks like it's incomplete. We will try another one. Oh, the answer is on the next page. When the variable resistor is reduced, the total resistance is reduced. So the current equals to E divided by total resistance. Current is increased. The fixed resistor has a bigger share of EMF. So the voltmeter reading will be increased. So donkey, can or not?
Yeah.
Kirchhoff's law. So you can remember memory word only.
C.
Boy,
Wait, what?
boy.
Oh,
Okay now. First law is
yeah.
conservation of charge. Second law is conservation of energy.
Okay.
Yep. This one cannot change at all. This one, you short circuit this one, so it's basically cannot change at all. This one also doesn't help. Right? You change this one, it doesn't affect this one. It's across the whole battery. The answer is C. Yep.
Okay.
Okay. Kirchhoff's current law. Yep. Memory, right? Going in is I1. Coming out is I2, I3, correct? A, okay now.
Oh, okay.
Yep. Can either calculate the potential difference across this one and potential difference across this one and then subtract to get that, or can calculate here, potential across here and potential difference across here. Right? Current, yeah, 12 volt between PQ. So it's V over total resistance, 12 over 1500. So there's a current through here. Then VPX, potential difference across here, is the current times 500. Current times 500, which is this one there. You get 4 volt. Then same thing